What are the quadrants of a trigonometric circle? So let us try to work it now. So let's say you got this as the first and the second line, which actually splits this circle into quadrants. So this is the first quadrant. I'm going to move in a clockwise manner. So we would say this is the second, this is going to be the third, this will be the fourth. Now each quadrant carries an angle of 90 degrees. So here you're going to have a 90, you're going to have a 90 here, this is also going to be a 90, and this will be a 90 also. All these add up to give 360 degrees. Now what we want to find is what the values of the trigonometric ratios for angles within each quadrant is going to give. Let us say that you have an angle within this form. So we're going to deal with this form. Now for this position, you would always have this sine. Well, that is all the trigonometric ratios present within that form is always going to be positive. So whichever value you have would always give a positive answer. Now here, that is just going to be a sine. And here you're going to have a t. And here you're going to have actually a c. There is a mnemonic that you could use to remember that. All science teachers course. So that is what you got. All science teachers course. Now that is if you are actually moving in this direction. Well, you might also decide to move in the other direction. Whichever direction of your choice, doesn't really matter. So let us start with the first quadrant. Now for the first quadrant, you have the angle to be less than or equal to 90 degrees. So if you have the sine of an angle within that quadrant, the answer is always going to be a positive answer. You're going to have a positive answer. So if I took a sine of 90 degrees, that would be a 1. That would be a positive 1. If I took a sine of 60 degrees, that is going to give a negative 3 over 2. Next up, we have the cosine. Cosine theta is also gonna give a negative, as well as a tan theta. So that is basically it for the first quadrant. Pretty easy, isn't it? Now let us move on to the second quadrant. Now for the second quadrant, you actually have the angles being greater than 90 degrees, but they are actually less than 180. So you could also write it this way. The angles are always going to be between 90 degrees and 180 degrees. Now for that, as we showed here, we have only the sign of the angle giving a positive answer. But these angles are actually obtuse angles. Obtuse angles are the angles that are greater than 90 degrees but less than 180 degrees. Those are obtuse angles. Now, if you have that, let us say this is a sine, and this angle is an obtuse angle. The answer is going to be a positive. But how can you change an obtuse angle into an acute angle? Now, there is actually two ways that you can do it. So this is actually going to be sine 180 degree minus theta. So that is going to reduce it to its acute form. Now remember, like we said further or previously, that you could also have a complementary form of this. Now this is going to be equal to cosine theta minus a 90 degree. Because obviously we know that this is going to be greater than the 90 degree. So this stuff is going to be equal. It's going to be the same. Let us try a question to solve that. Let us say that you have a sine 120 degree. This is going to give us a plus sine 180 minus this 120. So that gives us that gives us a sine 60 degree. Now sine 60 degree is actually root 3 divided by 2. Now we're going to work with this also. Now we know that that should give a cos 120 minus a 90. This is going to give us a cosine 30 degree. Now we know that cosine 30 degrees is also root 3 divided by 2, which is actually the same thing as this one. So these two stuff, they could actually be used. But it's actually wiser to get more familiar with this formula. So you just need to hold those at the back. Now how about cosine theta? That will be a negative. So you're going to have 180 minus a theta. This is going to be the same thing as a negative sine theta minus a 90 degree. You could also have this. Next up, we're going to take tan theta. This will be also equal to a negative, and you're going to have a 180 minus theta. So that is actually pretty much it for the second quadrant. Now let us move to the third. Now for the third quadrant, we actually have the angles being beyond 180 degree, but they're actually going to be less than 270 degree. Now, as you can see from here, there is actually only tangent giving us the positive. So sine here is obviously going to give us a negative. So how can we change the angles which are here from this form into their acute form? So here we should actually have it as a sine theta minus a 180 degree. That is how to change it. So if you have a, let's say something like a sine 240 degree, that should actually be a negative sine 240 minus 180. So that will give you a negative sine 60 degrees. And so that will be a negative root 3 divided by 2. Next up, we need to find out the cosine of it. That would also give a cosine theta minus 180 degrees. Now tan theta is going to give us a positive in this case. So that will be positive tan theta minus 180 degrees. So this is basically it for the third quadrant. Now let us move on lastly to the fourth quadrant. Now for the fourth quadrant, only cosine is going to give us a positive. Now we know these angles are actually greater than 270 degrees, but they're actually less than 360 degrees. So in this case, if you have a sine of it, sine of any angle here is going to be negative 4. So that will be sine of 360 divided by theta. Now, if you have a cosine of it, that will be positive. So this will be plus cos 360 divided by theta. And tan is also going to give a negative. So this will be a negative tan, and that will be 360 minus a theta. So that is basically it for the quadrants of a circle. Now, before we move on to solve some questions under this part, you just need to know that there are functions which are going to be odd, and there are others which are actually even. Cosine functions are always even. So if I have the cosine of a negative angle, the answer is going to be a positive cosine of that angle. But if I had a sine of a negative angle, the answer will be the negative of the sine of the angle. Same thing goes for tangent of a negative angle. You're going to have a negative tangent of that angle. So what that means is sine functions and tangent functions are actually odd functions. So these are going to be called as odd functions. and the other one is actually going to be an even function. Now, having got this, let us go on to some few questions under this part. Now, we're going to work these two questions and apply the principles that we've learned from the quadrants of a circle under trigonometry. Now, as usual, you can go ahead and pause the video and try to solve it by yourself. Come back and find out what is the answer. So let us start with the first one. So we have cos 210 and we have sine 225. Later, we have sine 210 and cos 225. And all these are actually getting manipulated, as you can see. So there is cos 210 minus sine 225 divided by sine 210 plus cos 225. So first, let us find out what cos 210 is going to give. So this is cos 210. Now, what is the quadrant to which 210 belongs? So if you draw this, this is 90 degree. This is up to 180 degree. And so this is clearly beyond that. This is going to be in the third quadrant. Now we have E, S, T, C. So in this case, it's only tangent that is going to be a positive. So every other trigonometric ratio would give us a negative answer. So that is going to be a negative cos. Now obviously this is greater than 180 degree. So we should have 210 minus 180 degree. Now this is going to give us a 30. So we have a cosine 30 degree. Now cos 30 is going to give us a root 3 divided by 2. So that will be negative root 3 divided by 2. So I'm just going to place it there. Cos 210 is actually equal to negative root 3 divided by 2. Now how about sine? Sine is also going to give us a negative. So this will be a minus sine 30 degree, because we need to take 180 degree away from this. That will give us 30 degree. So we know that this gives a negative half, so that will be minus a half. So I need to write it here also. Sine 210 degree is equal to negative half. Now next up, we need to find out what cosine 225 is. Now it happens to be that cosine 225 is also within the third quadrant. As you can see, this is a 90, this is an 80. So the 225th angle obviously lies within the third quadrant, where only tangent is a positive. So we just need to go with the negative. So that will be negative cosine, and here you're going to have a 225 minus a 180 degree. Now if you took 180 degree away from 225, that will give you a cos of 45. Now cos 45 is negative root 2 divided by 2. That is what you have. Now you need to know that cos 45 is actually the same as a sine 45 from the complementary angles. Now just as for sine 210, for sine 225, there is also going to be a negative. So this is also going to give us a negative 2 divided by 2. And that is what you got. So we're going to have a cos 225 here. That will be equal to negative root 2 divided by 2. And here we actually have a sine 225. So this is this is also root 2 divided by 2. Now having got all this, we're going to plug it back into the form of the question. So for cos 210, we have a negative root 3 divided by 2. And this is minus cos, well rather sine, and that is a negative half. Now divided by sine 110. Well, sine 210 rather. So am I making a mistake? Yeah, there is actually a mistake here. I needed to take sine 225, which is this stuff below here. So that will be minus root 2 divided by 2. Now here we have sine 210, which is this stuff. So that is a negative 1 over 2. And this will be a plus cos 225. So cos 225 is a negative root 2 divided by 2. So here now we're going to have a negative root 3 divided by 2. And then you're going to have a negative multiplied with a negative. That will be a plus. So that is going to be root 2 divided by 2. And here we have it divided by half multiplied. Now you have a plus multiplied by a negative. That is going to give us a negative. So we have a minus 2 divided by 2. Now here on top, we're going to have a negative root 3 plus a root 2 divided by 2. Why is that? We know that we need to add this by the method of fractions. Now the lowest common multiple between 2 and itself, it's 2. So that is going to be a 2 here. So what you have now is 2 divided into 2. That gives you 1. So you're going to have a 1 multiplied by negative 3. That gives you a negative 3. Now here you're going to have a 2 divided into this 2, and that would give you a 1. So you're going to have a 1 multiplied by root 2, which gives you a root 2. So that is why you have what you have here. And this is all divided by stuff which is below. So the same thing is actually going to happen. We have the lowest common multiple as a 2. So that is basically going to be a 2. And here now we have a 2 into this 2. That gives you a 1. And that will be a 1 multiplied by a negative 1. That gives you a negative 1. And similar thing is going to happen for this one. So that will give you minus root 2. Now here, you're going to have a negative 2 minus a 3. And this will be divided by 2. This is divided by this stuff. So that will be a negative 2 minus a 1 divided by 2. Obviously from here we could rotate this stuff and have it in another form. So this is going to be root 2 minus root 3 divided by 2 multiplied by 2. Well, so I need to write it out better. So this is minus 2 minus a 1. Now obviously from here, this is going to cancel. And you're going to have this multiplied by a 1 and 1 here multiplied by this. So that gives you a root 2 minus a root 3. And here you're going to have a minus root 2 minus a 1. So you can actually stop here. If you do not really want that, you could feel free to go further. That is trying to rationalize stuff, but this is pretty much something useful already. So let us try to see the answer to the next question. Here we have a cosecant squared. 3, well, that is a negative 330 degree. Now, we need to understand that this is a reciprocal of a sine. So this should be, so let us take it more gradually. This stuff could also be written as a cos negative 330 degree, all squared. As I told you, you could well take this part and insert it between the cosecant or the trigonometric ratio and the angle. Now we know that this stands for the reciprocal of a sine. So this should be 1 divided by sine negative 330 degree. This is what you have. And this all is actually squared. Now this stuff, we need to first of all understand that if you have the sine of a negative angle, because sine is an odd function, the answer should be minus sine 330 for 1. So this is going to be divided by minus sine 330 degree. And this is only as a result of the fact that you have a negative in there. Now we need to work sine 330. Now in order to work sine 330, you need to know the quadrant to which 330 belongs. And that is actually the fourth quadrant. This is 90. This is going to be 180. This is 270. And this is obviously the 200. Well, this is actually 360th quadrant. So this is responsible for 360 degrees. So in order to do that, you need to work up 360 minus 330. But you already know that we have a C being the only trigonometric ratio that is positive on that quadrant. Now sine is obviously not. So you're going to have another negative here in this way. So this is going to be a minus, and then you're going to have a minus again. So this will be 360 minus 330. And all this is power to the power of 2. Now we know obviously this is going to create a positive. So therefore we're going to have a 1. And this will be divided by sine 30. Now we know that sine 30 is actually equal to a half. So we have 1 divided by a half. Now 1 divided by a half is actually equal to 2. That is, you need 2 halves to make a 1. So this is what you have. But you need to know that this stuff was actually squared. So this 2 should also be squared. And that is going to be equal to a 4. And that is what you have. So I'm going to take these out and just try to write it here. Cosecant squared negative 330 degree. That is actually equal to 4. Now here we have a tangent. Notice that I have not actually taught you how to find the tangent of the special angles. Now this is it. The tan of 0 is actually equal to 0. And the tan of a 30 degree, that is actually root 3 divided by 3. And if you have the tan of a 45 degree, that would actually give you a 1. And the tan of a 60 degree, that will give you a root 3. And the tan of a 90 degree, that gives you undefined or complex infinity, because we cannot actually find that. Well, you could also use your hand trick to find it. In this case, you're going to use your left hand. So if we say this is a 0, this is a 30 degree, this is a 45, this is a 60, and this is a 90, you could find it from this form. Now for tan of any angle, you need to work the fingers below divided by the fingers above. But you need to use your right hand rather. So this is going to be the right hand. So you need the fingers above. Now fingers below divided by fingers above. So let us try to do it. Or I'm just gonna use this. So let us say tan 0. Now if you cancelled this part out, you can see that there is no finger below this 0. So that will be a root 0 divided by the square root of the fingers above. We have 4 fingers above it, so that will be a root 2. Now this will be a 0 divided by 2, which is a 0. So that is why we said tan 0 is equal to a 0. Now let us try for just one more. Let us try to find it for 30. Whoa, that is a mistake for this one. So I'm gonna take this out again. So we have tan 30. Now, square root of the fingers below. I need to ring it out. So this is a 30, right? So if we fold it or cancel that part, you're going to see that this part is actually the only stuff which is below the 30. So that will be a 1 in it. Now here we're going to have a square root of the fingers above. This is a 3 in it. So this is going to be a root 3. And this is actually going to give us a 1 divided by the root 3. Now, notice that stuff which we have on this other side is not actually equal to this for now. That would actually be just from face value. But if you went further to rationalize this, you're going to see that this would give this. So let us try to do it. I'm going to try to rationalize. So that will be 1 divided by a root 3 multiplied by a root 3 divided by a root 3. Now this multiplied by this is going to give us a root 3. And if you have a root 3 multiplied by a root 3, that will be root 9. Now root 9 is the same thing as the square root of a 9, which is a 3. So the answer is going to be a 3. Root 3 rather, divided by 3, which is exactly what you see here. So that is basically where it came from. So hopefully by now you know these angles and how to find them with your hands. Now let us go further to find out tan 330. Now tan 330, just as usual, 330 is actually within this quadrant. So that has only the cosine to be positive. That means tan is going to be a negative. So this would be negative tan 360 minus 330 degree. So this will be minus a tan. Now this should give us a 30. We already know that tan 30 degree should give us a root 3 divided by 3. So since we have a negative here, that should be a negative 3 divided by 3. Now from here, we can work everything together. We need to find cosine or cosecant squared of 330 degree. And that is actually plus tan 330. Now this whole stuff, we have actually already found it to be a 4. So that is going to be a 4. And this stuff actually gives us a negative. So this is negative root 3 divided by 3. Now let us try to find the LCM between this. We know that 4 is the same thing as a 4 divided by a 1. And the lowest common multiple between this and this is actually a 3. And if we took 1 into a 3, that would be 3 times. So that would be 3 multiplied by 4. That gives us a 12. And here we have a 3 divided by 3. That gives you a 1. And so you have 1 multiplied by negative root 3. So that will be negative root 3. So there is actually 2 possible answers. You might be given 4 minus a root 3 divided by 3, or a 12 minus a root 3 divided by a 3. So all these are actually viable answers that you could actually be given. So that is basically it under quadrants of a triangle.